Okay, I plan to give you some tips on how to solve this particular task. First thing that I would suggest is that you take a look at the equations and identify the constants that are in the equation, because we're going to try and identify those. One constant is the k. It says that both k values are the same. You just have to watch out for the units. I'll talk a little more about that later. So that's a constant that we need to identify for the motor. The other constant is the resistance of the motor. All of the other non-highlighted terms, they're all variables. They change as you operate the motor. Okay, so the number of variables that are left is 5. T, I, VB, omega, and voltage V. So we have 5 variables, and we're going to use 2 of the equations to eliminate 2 variables. And so what you're going to be left with is 5 minus 2 is 3 variables. So I'm going to eliminate 2 of the variables. So the question is, which 3 variables do you want to leave in the equation? Well, it tells you right here that you're looking for torque, voltage, and motor shaft speed. That's omega. So it tells you that you want to keep these 3 variables and get rid of the others. So what we're going to do is use two of the equations to solve for the 3 variables. Okay, so what you see here in red is solving the first equation for the current I, and then the second equation is already solved. That's the VB. I and VB are the 2 variables that you want to get rid of. And then you take these 2 quantities, you put it into the last equation, so you end up with this equation right here. Now, if you notice, that equation has the 3 variables, and only the 3 variables that you're looking for. Now, the only problem that's left is to try and identify the 2 constants, R and K. So the way you do that is essentially the same way that you find the constants of integration. What you want to do is you want to find values of these 5 variables: the torque, the current, the VB, the omega, that you know, and then you substitute into the equations to try to find the values. I'll show you what I mean. Okay, I have pulled up one of the motor specifications, and if you look at this right here, they give you the information that you need right there. So they're telling you a speed, a current, a voltage, and a torque. So I'm going to take these values and I'm going to put them in to the motor equations. Okay, what I've done over here is I've just copied in the data that came off that data sheet. And what we're going to do is we're going to substitute these numbers into the 3 equations that you have. Now, you can't do it with these units. You're going to have to convert the units and make sure that you do that. So I'm going to leave that as an exercise to you. But basically, the top equation, you're going to say, I know the torque is 135. Watch out for the units, okay? Equals K times the current times the voltage. The voltage is, or excuse me, the current. The current is equal to 452 amps. Okay, so from there you can solve for K. Now again, watch out for the units. Make sure that you put it in consistent units. Okay, now for the second equation, I don't know VB, but I do know omega. Well, let's skip down to the third equation. You know the voltage. The voltage is equal to 72. Well, okay, let me back up. Let's put into the second equation. Second equation, I don't know VB, but I know it's equal to K, which you can get from the top equation, the top blue one. K times omega. Omega is 1442. Again, watch out for the units. You can't just divide this out. You've got to watch out for the units. I'm going to leave that as an exercise to you. So the point is that you can take the top equation once you convert your units, and you can get the K. Once you have the K, you can take the K and you can stick it into the second equation, and you can get the VB. Now that you have the VB, then you can put into the bottom equation. You say your V is 72. You know your VB, so you just bring it down. And that equals R times I, and I is equal to 452 amps. Again, you got to watch out for the units. What this allows you to do then is to go in here and calculate the R. So that's how you find the two values that you need for the motor. All right, so in order to finish this, each motor is going to have its own value of K and R because they're different motors. So you're going to take this equation right here, and after you figure out your units, you're going to be able to know the R and the K. So this gives you an equation for the torque in terms of the speed, and you can make a plot of this. Torque on the Y, omega on the X. And then for the V, you're going to put the V in as the maximum V from the motor specification. I'll show you where to find it. Okay, so here is the motor specification, and it tells you what the maximum voltage is right there. Essentially, the motor can be driven with any voltage that you want. The faster you want your motor to run, you apply more voltage, and you'll see that from your equation. So what they're showing you is that when they tested it, when the manufacturer tested it, he applied these numbers to the motor, and this is what he got. What he's also telling you is don't put more than 190 volts on it, or else you're going to have problems. So you can apply whatever voltage you want. If you don't want the motor to run, you apply 0 volts, the motor won't run. If you want it to go faster, you apply greater voltage on the motor, and it'll go faster. Okay, so when you're doing this plot, you'll know what the voltage is for each motor. You know what the K is. You know what the R is. You know what the K is, and so you can make a plot of T versus W, which is not hard to do. You can probably look at that equation and see what kind of equation it is, whether it's a linear or what. Now, in order to determine the T max and the omega max, you don't have to plot it, right? I mean, plotting it, it's obvious where it is. But if omega is equal to 0 is where the maximum occurs, put a 0 in here. You know all the other numbers. Put a 0 in there. What do you get for the torque? You get the torque is equal to the voltage, the maximum voltage, because you've applied the maximum voltage, equals R over K times T max. So you can calculate T max or read it off of your chart. It also says to find the omega max when torque equals 0. So what you can do for that one is go in there and you put in a 0 for the torque and solve for omega. And what you'll find is that voltage max from your motor minus K omega max is equal to 0. So your omega max is going to equal the voltage max divided by K. And again, the voltage that you apply, it depends on you. You decide how fast you want it to go. And the greater the voltage you apply to the motor, the faster it moves. Same thing over here. The greater the voltage you apply, the more torque you get. Okay.